Okay, here we're going to go over the problems from the true-false section, which deal with two things. One, the definitions of validity and soundness, and two, implications or equivalences in between logical formulas. So let's just start with the valid sound questions. If an argument is sound, then at least one of its premises is true. That's true. And the reason it's true is quite simple. If an argument is sound, all of its premises must be true. And if all of its premises are true, then at least one is true. So it's true. Next, if an argument is sound, then it has at least two premises. That's false. Remember, we said the argument P, therefore P, is valid. So anytime P is true, that's a sound argument. So if I say, I'm a human being, therefore I'm a human being, that argument is sound, supposing, of course, that I'm a human being. Next one, if an argument is sound, then it's valid. That's true, and it's true because sound just implies valid plus true premises. That is, there are two necessary conditions for an argument to be sound, and they are that the argument be valid and that it have true premises. And those conditions are incidentally jointly sufficient. But since validity is a necessary condition for soundness, it follows that if an argument is sound, then it's valid. Next up, if an argument is valid, then it's sound. That's false. Why? Because validity isn't sufficient for soundness. In order for an argument to be sound, it needs two things. It needs to be valid, and it needs to have true premises. But this claim here, if it's valid, then it's sound, acts as if it only needs one thing, as if it only needs validity. So this claim is false. Next, if an argument is unsound, then it's invalid. That's also false. Why is that false? Because there's two ways for an argument to be unsound. One way is for it to be invalid, and the other way is for it to have false premises. So if you have an argument that is valid but has false premises, it's unsound. Moreover, it's unsound but not invalid. So it's just not true that if it's unsound, then it's invalid. Next one, if an argument is invalid, then it's unsound. That's true. It's true because soundness implies validity. And since soundness implies validity, invalidity implies unsoundness. To put it another way, being valid is a necessary condition for being sound. So if you're invalid, you can't be sound, because validity is a necessary condition for soundness. Next up, if an argument is valid, then it's sound. That's false, because soundness requires two things, and this statement acts as if it only requires one, right? Soundness requires both validity and true premises, but this statement acts as if it only requires validity. It says if it's valid, it's got to be sound, but that's not right, because it could be valid, have false premises, and therefore be unsound. Next, if an argument is sound, then it's invalid. Well, that's pretty obviously false, because if it's sound, it's got to be valid. Next, if it's possible for the premises of an argument to be true, and yet the conclusion is false, then the argument is sound. And that's false. If it's possible for the premises of an argument to be true, and yet the conclusion false, that means the argument is invalid. And a sound argument has to be valid. So this amounts to saying if an argument is invalid, then it's sound. Well, that has to be wrong. Next, no unsound argument is valid. Well, that's false, because you can have valid arguments with false premises. So if I say, if I'm king of the United States, then my name is Stephen. I'm king of the United States, therefore my name is Stephen. That's an example of a valid argument. It has the form if P then Q, P therefore Q, but it's unsound. It's unsound because it includes the false premise that I'm king of the United States. Next, if an argument has all true premises, then it is sound. That's also false, because an argument can have all true premises but not be valid, and soundness requires validity. So here's a simple example. If I say, my name is Stephen, therefore the moon is made out of cheese. Well, the only premise of that argument, my name is Stephen, was true, but the argument isn't sound because the conclusion doesn't follow from the premise. It's invalid. Okay, those are examples for the valid, invalid definition section. What you want to do for this is really work through all the practice exam problems and see if you really understand the distinction between validity and soundness. If you run into a particular case where you don't understand what to say, whether it's true or false, feel free to email me and I'll let you know. Next, P if Q implies if Q then P. That's true. So think about it like this. You're a sibling if you're a sister implies if you're a sister then you're a sibling. Next one, not P or not Q is equivalent to if P then Q. That's true. Remember the rule of material implication, which we talked about, says this. It says that if P then Q is equivalent to not P or Q. And the idea there is this here says either P is wrong or Q is right, which means if this one here, not P, is false, then Q must be right. So if not P is false, then Q must be right. Well, not P is the same as P. So not P or Q is the same as P arrow Q. Okay? Now, over here we have P, we have not P or not Q. And we want to see, is that the same as P arrow not Q? Sorry, I'm mistyping here. P arrow not Q. Well, what is it for not P to be false? It's for P to be true. So if not P is false, that's like saying it's not the case that not P. And this formula says either not P is false, if not P is false, then Q must be true. So it says if not P, sorry, it says at least one of these must be right, which means if this one is wrong, which is to say if not P, then this one must be right. So if not P, then not Q. Now not P then is the same as P, so this formula here, if P then not Q, is the same as not P or not Q. So that's true. Next one, P only if Q implies if Q then P. That's false. Remember, P only if Q preserves the order, so you're a sister only if you're a sibling. It says if you're a sister, then you're a sibling. But this acts as if it says if you're a sibling, then you're a sister. And that's wrong, so it's false. P implies P or Q. That's also true. This is the rule of addition we talked about before. Why does P imply P or Q? Because this requires that only that at least one of them be right. Well, if you know P is right, then you know P or whatever else is right. What makes this P or whatever else right? The fact that P is right. Next one, P and Q implies Q. That's also true. If I know I have a left hand and a right hand, it follows that I know I have a right hand. Next one, I won't have a problem that requires you to understand parentheses this way on the actual exam, but I'm just going to walk through it anyway. This says P or Q. And this says it's not the case that that disjunction P or Q holds. Well, if it's not the case that P or Q holds, and P or Q only requires that at least one of them be right, it follows that it's not the case that either of them is right. And to say it's not the case that either of them is right is to say neither of them is right, which is to say P is wrong and Q is wrong. So this one is true. Finally, not P implies not P. Well, that's false because not P implies P. It can't imply not P. Okay, and that's all of these problems. And again, I recommend working on some of the other practice exams as well as thinking through this one.